Hello everyone, welcome to the course Data Structures. This is Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. Today we will be seeing the overview of single linked list insertion operations. As we have seen in the previous session, single linked list creation and display operations. Let us see what are the different operations we have in single linked list insertion. We can able to insert a new node at the beginning of the list. Then we can insert a new node at the end of the list. Then insert a new node after the given element. And insert a new node before the given element. Let us see how we are going to perform all these operations in single linked list one by one. Let us consider the first one, insert a new node at the beginning of the list. Consider this is a single linked list with the 3 nodes, which refers the first node as head and last node as last. Now, I want to insert a new node at the beginning of the list where I am going to allocate the memory dynamically and n-arrow data. That means in this data part I am going to insert the value as 5. In the address part, that is n-arrow next is going to be initialized to null, and the name of this node is n. The address of this one we have considered it as 5000. Like this way, memory is allocated for a new node and data and null values has been initialized. Now, this has to become the new node and we need to make the connection from the existing head node to this current new node. How we can make this one? Connecting the nodes between the new node and the existing one, where we are going to store the address here, that is 1000 is going to be stored in this location. For this, what is the statement we are going to write? That means we are going to write, this is nothing but n-arrow next equal to head. We know that the name of this node is head, that's why we are going to make the connection n-arrow next equal to head. After writing this statement, now we are going to assign this head to the first node. Why? Because we are inserting a new node at the beginning, that's why this becomes the head node. For this, the statement where we are going to write is head equal to n. Let us look into the code, how we are going to write the code here, where we are going to allocate the memory by using malloc, and in the data part we are going to read the data value. In the next part we are going to initialize it to null, and the name of this node is n and assigning the address as 5000. Now, we have seen that how we have initialized, that is n-arrow next equal to head and head equal to n. We are assigning head equal to n. In this way, we are going to insert the node at the beginning of the list. The next operation is insert a node at the end of the list, where here also we are going to consider the single linked list with the 3 nodes, where it is going to refer the first node as head and last node as last. Now, I want to insert a new node at the end of the list. That means here I want to insert. For this, what are the steps we are going to follow? Again, the same thing. We are going to allocate the memory dynamically by using malloc function and inserting the data value as 40 and address part as null. And the name of this node is n and the address which you are going to assume is 4000. Now, this is the last node. Now, the new node which you have entered, that has to become the last node. That means we need to make the connection between the last node and the new node. Now, establishing the connection between the last and the new node which we have inserted at the end. Now, we are going to store the address of the new node into the last, like this way with 4000. Now, what is the step we need to write it here? Name of this node is last, that's why we are going to write it as last arrow next equal to n. This is the step where we are going to represent. Now, After inserting the new node at the last, now this becomes the last node. That means we need to assign last to the last node. That means we are going to make a statement last equal to n. Now we can see this is how where we are going to write the code for this. We are going to allocate the memory, and that is referred with the address n. In the same way, memory is allocated and name of this is n, and we are going to read the data value as 40, and we have initialized this to null. These are the two steps where we have followed. And the last node we have seen, the last node that has to be connected to the new node which we have created. This one is the last node and this is the new node which we have created. We need to make the link between these two. That means we are going to write the statement last arrow next equal to n, and at last we are going to make this last node which we have inserted as a new node, that becomes the last node. Like this way we are going to implement the insertion at the end. The next one which we are going to see is about insertion after the given element. Now consider the same situation where we are going to have a single linker list with 4 nodes, which refers the first as the head node and last as the last node. Now how we are going to perform the insertion of element after the given element? That means we are going to insert a new node after the given element. Consider I am going to insert 25 after 20. 25 is a new element which I am going to have that will be placed in the new node, and after 20 element I want to insert it, right? First, for that what we need to do is we need to search the element in the single linker list. For that, for searching the element in the single linker list, we are going to use a temporary variable that is going to move in between head and the last. Now I am going to search the element whether that is present in the list or not. Based on that we are going to allocate the memory and then we are going to insert it. Now try to do this. Temp is representing the head, that is it is representing head, and temp are representing the same location. Now I am going to search temp arrow data is 20. No, temp arrow data is not 20. What we are going to do in this case? Now we are going to move our temp to the next location. Now temp will be moving to the next location. Now temp is pointing to this location. Now I am going to search temp arrow data equal to 20. Yes, now temp arrow data is 20. Because of that the element is searched. Now what we are going to do here? We are going to allocate the memory, and we will be having the data part as 25 and address part as initially it is null. Then we are going to make the connection, and we are referring this with the address of 5000 and the name of this node is n. Okay. Now temp is pointing to this location. Now we need to establish the link between the new node which we have created and the existing nodes. For that we need to identify what are the names of these nodes. Yes, we know that the name of this node is temp and the name of this node is n. Then what is the name of this node? This has to be identified when I want to establish the connections, right? The name of this node is temp. The name of this node is nothing but temp arrow next. Why? Because the next address we are going to store it in temp arrow next. That's why the name of this node is temp arrow next. Now make the connections. Here n, in this address part we are going to store the address of this temp arrow next. That means what we are going to write the statement, n arrow next equal to temp arrow next. This is the statement where we are going to write. Next we are going to connect the n with the temp node. That is nothing but, what is the statement? I can write it here. This is nothing but a temp arrow next. temp arrow next equal to, the name of this node is n, where I am going to store 5000 here. That means, observe, this is the change, you can look it here. 5000 is going to be stored in this location. Temp arrow next equal to n. These are the statements where we are going to perform when I am going to do the insertion after the given element. Let us look into the logic, how we are going to write the logic. First, allocate the memory. We have allocated the memory for the new node which we are creating, and we are reading the data value as n arrow data as 25 and address part as null. And these two statements we have completed. After that, we need to read a key value to search whether the key element is present. Based on the key element, we need to insert the new node after that key element. That's why we are going to read this key part. Then, to traverse through your list, we are going to initialize one temporary variable temp equal to head. Temp will be moving in between head and the last, where you are going to find the key value, there it is going to terminate. To iterate through your loop, we are going to check temp not equal to null. If temp not equal to null, if it is not the last node, then what we are going to do? We are going to check whether your temp arrow data equal to key or not. It reaches the key value as 20, then you will be coming out of the loop. If not, we are going to move our temp to the next locations in the list. Okay. Next, after doing this, if we have reached the key value, now we need to make the connection between the new node, the node which we have created, and this one, like this way. We are going to do it. For that, the statements which we have written is n arrow next equal to temp arrow next and temp arrow next equal to n. Like this way, we are going to implement our insertion of new node after the given element. Next, we have one more operation which we are going to perform, insertion of new node before the given element. Before the given element. Now, here also we are going to consider a single linked list with 4 nodes, and where here we are going to refer the first node as head and last node as last. Now, look into the insertion part, how we are going to do that. Here we are going to take one temporary variable. Not only that, we are going to take one more variable also, that is nothing but P1. We are going to assign P1 equal to temp. This one also we are going to do. That means P1, temp and head all are referring to the same location. Okay. Then we are going to allocate the memory, that is 25, and we are going to have initially the address part is null. And the name of this node is n, the address is 5000. Like this way, the memory is going to be allocated. Now, to insert a node before the given element, suppose insert, again I am giving 25 before the element 30. That means I want to insert the element before this 30. Now, what I am going to do? I am going to traverse this temp through my single linked list, so that I can search the element 30 is in the list or not. If it reaches 30, then I am trying to insert my new node into my single linked list, right? Now, first I am going to check my temp arrow data. Temp arrow data is 30 or not? No, it is 20. That's why we are going to move our temp to the next location. Now, moving temp to the next location. Before moving temp to the next location, we are going to assigning our P1 equal to temp, right? Moving our temp to the next location. Why? Because we will see what is the use of this. Next, I am again checking my temp arrow data is 20. Is 20 is equal to 30? No, again. Now, again I am moving my temp to the next location. That is, temp is moving to The next location is 3000. Now it is pointing to here. When I am going to do this, now before moving my temp to the next location, I am assigning P1 equal to temp. When I am moving P1 equal to temp here, this won't be existing. Now P1 is pointing to this location. Now identify the nodes, name of the nodes, and then make the connection between them. The name of this node is P1. The name of this node is, you can give it as P1. The name of this node is N, and the name of this node is temp. Right? Based on the identification of these nodes, now make the connection between the new node and the existing nodes. Now what is the statement? I need to write it here. Now I am going to store here, right? N arrow next. This statement is nothing but N arrow next equal to, the name of this node is temp, right? The name of this node is temp. Like this way we can give. And another one where we are going to store 5000 here. That means I need to establish the link here. This is nothing but, this is your P1 value, right? P1 arrow next. P1 arrow next equal to N. Like this way, we are going to establish the link and we are going to insert the new node before the given element. Okay. Now, we can see the code how we are going to write for this. First, we are going to allocate the memory as in the previous way. And reading the data value, same 25, and initializing with address part as null, and the address of this is 5000, and we are naming referred with N. These are the steps that are included. After that, we are going to read the key element. The key element is 30 we have taken. Based on that 30, we are going to traverse through the list. Now initialize temp equal to head, where we are going to use the temp value for traversing through head and last. Now iterate the loop until temp reaches the null value. In between that, when I am going to reach the key value, I will be breaking out from the loop. I will be coming out of the loop, and based on that the following statements are executed. And if it is not the case, if the key value is not found, in that case what we are going to do? We are going to assign the P1 equal to temp, and temp will be moving to the next location. If this is done until your key value is found and the temp is not equal to null. If temp reaches the key value, in that case we are going to assign N arrow next equal to P1 arrow next. Either we can write P1 arrow next or we can write temp also. Temp also. Both is going to work. Next, P1 arrow next equal to N. These are the steps where you are going to follow, where you are going to insert a new node before the given element. Now we will be seeing the overall summary what we have discussed in the single linked list insertion operation. The insertion operation we have looked into. The first one, inserting a node at the beginning of the list, new node, and we are going to insert a new node at the end of the list, and we are going to insert a new node after the given element, and insert a new node before the given element. These are the 4 operations where we have performed. I hope you understand this. Thank you. We will be seeing the implementation part in the next session. Thank you.